Yeah, so yeah, next we have a community demos from Wenja and then Johnny. So yeah, Wenja will present her recent work on SAD dump log tool. So I can give you some context. So SAD write like distributed consistent log over raft for durability, and then the underlying storage layer is write ahead log WAL. So this is separate from the key value backend storage layer. We encode like raft log entry in protocol buffer and keep appending that like new entries to the WAL file. So let's say client sends a like write request. This proposal like first goes to the leader, and then when the proposal has been agreed by the majority of the cluster, like leader commits that entry, and then when we commit, we append that entry to the WAL file. And then this committed log entry is persistent. And then when we say commit, it means like write down, like fsync down to the disk, like which gives like durability. And then if the machine crashes, like crashed, like restarting server can just like reply the like logs back from the disk. And then fcd dump log tool is for this like write ahead log storage. Like it contains all the committed like entries and the raw data. So there are many things we can do with this tool. And then next is Johnny from BrainTree will present their recent work on list storage. And then their SCD use case. Like BrainTree has been pushing the limits of like SCD like list storage, and then have been helping us a lot to make the list storage like scale better. So Wenja, you want to go first?
Yeah, sure. Thank you, Guy-Ho, for your introduction. That saved me a lot of effort. So I'm gonna share the screen now.
Yeah, let me stop sharing.
Please let me know if you now can see my screen.
Yeah, I can see.
Okay, great. Yeah, so I'm gonna talk about the latest improvements in SCD. I was going to go over what is SCD dump logs, but thanks to Guy-Ho who already did that, and then we'll go straight into the two major improvements, and then we'll do a short demo and go to the question and answer sessions. So yes, as Guy-Ho already said, SCD dump logs is a tool in SCD that dumps the log from data directory, which include the snapshot and the WAL log. And then this is just an example of what the SCD dump logs output look like. So you give it the data directory, path to the data directory, and then you can see that it output the term, index, type, and data of each record entries. And then you can see here we have some config changes, we have some sync requests, some range, some transactions. All right, and each WAL log is 64 megabytes, but depends on the length of the request. The number of entries in each WAL log could vary. And in this particular ones, it has more than 93,000, a lot of the entries. So in that case, if we only want to see the config changes from this WAL log, we will take a while for the human eyes to do the analysis. And a second problem we can see here is if you look at this particular entries, the value to it is not readable. It's actually because when Kubernetes put the object into the SCD, it was encoded. And yes, now we get the log from the WAL log. We still don't know what is in there. So that will lead to the two improvements that we have added into this tool. The first one is that we added an entry type flag, which for that you can put in whatever types that you are interested in. Could be one, could be more than one, and then when the dump logs dump the log from the WAL log, it would filter the entries by types. For example, if you're only interested in transactions, it gives you just the transaction entries with the count of that particular entries, or you can have more than one. It would output those two types of entries. So then we have a second improvement, which is to add the decoder support. For this one, if you specify the path to your own executable decoder for the flag stream decoder, when the SCD dump logs dumps the data, it will decode each entry based on the logic in the path decoder. Basically, how it works is the SCD dump logs would output the binary string of the WAL log, entry by entry, to and pass it to the decoder, and then decoder would take that, decode it, output the decoder status and decoded data in certain form as stated in the slide. And then the SCD dump tools would take that output, pass it into the output. And you can see before we only have term, index, type, and data columns. And if you use decoder, then we will have two more column, decoder status and decoded data. So to explain the usage of this flag, I just wrote a very simple and meaningless, decoder. What it does is it just interpret the integer, transfer the integer into characters. And if the string is longer than 20, it would give OK decoder status. If it's short, it will have an error status. So you can see we have the data column here, and we have a decoded data, which is the translation from the decoder, and we have the status here as well. And if your decoder does not output the decoder status and decoded data in this way, you can still use it. We will have for the decoder status, we'll say that okay, the format is not right, but we'll print out the output anyway, and then whatever come out from the decoder would be put in the decoded data. So with that, I would like to present to you a real-world use case, like a real decoder that we use in Kubernetes. So if you haven't heard of Augur, it is a tool that Joe Betts developed to decode and encode the Kubernetes object, and it's used in Kubernetes a lot. So it have a couple of different commands available. The one we're gonna use and integrate with the SCD dump logs tool is Augur decode. So with that, I want to go into the demo and show you how to use it. So here I have a latest SCD, and then now we're gonna build the tools SCD dump logs here. Now we should have a SCD dump logs here, executable, and then we can do help. You can see all the available flags, like the start index and start snap are the ones that been there since the first day the tools was created. That's the starting point where you want to, when you want to recover your system, you want the start point, which could be an index or a snapshot file. And then you replay the WAL log starting from there. And the entry type and stream decoder are the new features that we had. So let's look at one of the data files. say, let's see, no such files. Logs. All right, and how about we put it into output, and then now see output. Oh, misspelled. Sorry. All right. So at the beginning, there are some metadata, and then we can see the 4 columns of term index, type, and data. And this is the one of the test cases that I built. It contains all the possible things that we could, the possible mutation that we could put into the WAL log, including you can see some lease grant, some off, and at the end, it would give you the count of all the entries. And then if we want to look at just say entry type of transaction, right? Our transaction. Now you can see that it only output 1 entry, and I've heard earlier there has been some issues on lease grant and lease revoke. We can output those. And grant. All right, now we have 2 entries, one of each. So those are the test data I have. Now I want to show you one of the real SCD WAL log data from Kubernetes SCD. So let's see the transaction from SCD data. All right. So this one so for this one, you can see that it started to have this, it output all the transactions. And in this part here, the Kubernetes object is encoded. And if we add the stream decoder in there, so this is where your decoder is. And then these are the decoder argument. When we output that, now we can see, you can still see the encoded string here. But other than that, we have a decoder status as augur, okay. And then we have a decoded data printed here, which it makes a lot more sense. It actually means something to me, right? All right, I think with that, we still have some future works to do. For example, like the formatting now is not perfect. The way we want to do it is that we just try to append everything in one line. So if you already have some sort of script that analyze the WAL log dump, then it won't affect your work. But and then still you can still see the decoded data. But it certainly can be made better. And then we can see, for example, the auditing work is also can be done based on the analysis of WAL log. So there are still a lot of things that we could do there. With that, is there any questions?
Yeah, I just want to mention that I like how we do all the like end-to-end tests for the STD dump log tool. Like it has really good coverage, and then with the entry filtering that you added, like the tool itself is now much more useful. So thanks for working on that.
Thank you.
Any other questions?
Yeah, if you have any other use case you think would be useful for you, we would like to collect those and see what more improvement we can do there.
Okay, sounds good. Thank you.
Yeah.
And then next on Johnny, like, do you want to go next? Oh, we cannot hear you. I think you're muted.
Hi. Can you see the slides?
Yes, thank you.
Okay, great. So I'm Jonathan Calvert, and I've got my two teammates here as well, Brian Cosgrove and Micah Gates.
Yep. I'm going to go ahead and introduce our use cases, and then Micah and Johnny are going to talk about both some of the things that we did to configure etcd and address like environmental concerns, as well as some of the open source work that we've done for etcd to address some of the scalability concerns that we found. So yeah, so I'll just start by talking about our use cases. Our major use case is task-based locking. So for the duration of a task, we lock a shared resource in etcd. We do tens of millions per day in our system. So these locks are very, very short-lived, only for the duration of a request. The typical duration of a request is 1 to 1.5 seconds. And then we actively revoke leases at the end of a request. This more or less worked just out of the box. I think barring some, environmental issues that we ran into in our hosting environment, as well as some configuration work we had to do. So our other major use case that we ran into a little bit more difficulty on was giving us the ability to prevent duplicate actions for a time after a task completes. Typically we try to prevent duplicate actions for up to 1 hour, but it can be in some situations up to 24 hours. These leases are very long-lived. They're fire and forget. We want them to be revoked by etcd server side. And we do tens of millions of these a day. So those are our two major use cases. Micah, do you want to talk about some of the things we did?
Yeah, I think I can take it. Can you not hear me?
Hear you.
Yeah, so a couple of the things that we tried. One was doing custom compaction schedules, right? And so to smooth out compaction spikes in heavily used clusters, we made our compaction schedule with a cron job compacting every minute or two. This was something that we found seemed like there were several other people who were using custom compaction schedules. For us, this was something that we had to do because we saw quite a bit of performance degradation if the compaction period was too long. So if we just left it, doing it if we left it where we were compacting every hour, that was not very good for our performance during that period, and we need consistent throughput. So there's still a lot of the new auto compaction options that were released in 3.3, but we had a little bit of trouble trying to tune that to get something that was along the lines of what we were expecting. So it's a little bit interesting for us because we very rarely ever need to look at the past state or the previous value. For us, pretty much if those values have changed, you know, we just need to know what the previous, that there was a previous revision. We don't really need to go back deeply, so we don't need to look back in time, so we can keep our compaction window pretty short. We've made some changes that we'll talk about later, so we probably need to go back and reevaluate our compaction performance. Oh, wrong direction. Slides, how to do it. Lease revocation is better than key deletion. Leases stick around, even if the only key attached is deleted. So if you grant a lease and attach a key to it and then later delete the key, the lease hangs around. So this ended up being a serious problem for us because we ended up loading our etcd cluster with millions of leases over time. So this, of course, helped to go away once we decided to actively start revoking leases. And then, of course, once we added some changes that we'll talk about a little bit later to help with leases piling up in etcd. So, like I said, having lots of leases in flight was killing performance. We were getting to the case where we'd have 5-6 million outstanding leases, and the find expired leases function in the etcd lesser basically had a linear time scale where it would traverse through the entire lease map to try to find the expired leases. So needless to say, this works well when you have a relatively small number, but once you start scaling out to a much larger number, you start having problems. So we went in and we added a go heap. So that's a sorted store. So when things are pushed onto the heap, it's put in a sorted position. So that means that we are able to then look at all of the leases, and when we get to one that is not yet ready to be expired, because we can look at its timestamp, we know that we can just short circuit. So this gives you a nice logarithmic performance. And then we also have some issues around the index compaction. So the KV index, which is just the index of all the key values, we were getting it up to 5 to 10 million. Oh, I did. I'm sorry. We did. I skipped something. Yeah, this is actually pretty important. So we ended up moving etcd to write to a RAM disk. So we have our own virtualized environment. If any of you have ever had any kind of experience with that, you may find that you're sharing some hardware with some Elasticsearch nodes or something like that. Things that can have really bursty I/O, and if you don't have the benefit of something like provisioned IOPS like you do in Amazon, it can be difficult to try to find the right host where you don't have to contend with this. So because we couldn't consistently get the kind of disk write guarantees that are really suggested and necessary to get high performance out of etcd, we just started writing everything to a tempfs file system. So that really helped our performance. The caveat, though, is that that means that this data goes away if you reboot the node. So we had to write some scripts and tooling so that we can be able to copy data from into durable storage after dropping a node out for maintenance or upgrades. Yeah, and back to, like I was saying, compaction. The KV index, when it gets large, the KV index is basically a B tree, but the compaction process would hold a lock while it traverses this B tree. And again, this is something that is fairly quick unless you start getting millions and millions and millions of keys like we've had. And then it turns out that you're holding that lock for a significant period of time. And if you're holding a lock on the key value index, that means that you have a bunch of writes that are piling up. So if you have a particularly write-heavy usage like we do, this causes problems. So the way that we looked at that was we said, okay, well, we can actually clone the tree index and then only hold the lock for the individual entries in the index. That means that this allows all the competing functions or Go routines to essentially get in there and be able to access the index. So that significantly smoothed out our process. And thanks to Guyo and the rest of the etcd team for helping us out, getting this done and merged in, as well as the heap changes. So I'll turn it over to Micah now.
Yeah, so we still have some things we're working on. Like at the start, we didn't quite have a good grasp about how, leases aren't really for TTLs. So, for performance reasons, obviously, actual lease expiration isn't shared among the cluster. So it means it gets reset every election, which is pretty tricky for long-lived leases. So, it would be great if they had a reliable TTL. That's something we might work on at some point. But for now, we just use sort of client-side enforcement of the timing and then just make our keys expire so that our database doesn't fill up forever. And it's working pretty well for us. We've been having some trouble with like cluster membership rejoining. It looks like when we have a lot of data and a lot of activity, it's like often hard for a member to be able to rejoin. We haven't quite run this to ground yet, but we've had like a number of times where we have to sort of reinitialize a member from scratch. So we're still working on that. We did have like a particular problem where having a lot of leases in flight kept leader elections from happening because we think the lease initialization process, where we change the lease expiration to the length of the lease every time there's a leader election to ensure that it doesn't expire prematurely, iterates through all of the leases and resets them all. And has locks along the way. And that was taking so long that we couldn't actually get heartbeats out. So we ended up, there's a pull request outstanding, which I think we're still working on, or we're still waiting for feedback on, which basically does this in the background. Oh yeah, those are all our pets. Which does it in the background, and hopefully that will solve this problem and make sort of like leader elections happen quickly, and then as the member is ready to start expiring leases, having rewritten them all, it can start doing that. Yeah.
And this issue is currently making it hard for us to do the second use case that we talked about at the beginning.
Right. Yeah. Having lots of in-flight leases is making that tricky. So, and then we, as an apology for our very plain slides, we have pictures of all of our pets.
Okay, thank you so much. Yeah, I have a question. So how many nodes do you guys have in per cluster?
We're mostly doing 5-node clusters.
And then most of the list is like 24-hour ETL.
Many are 24 hours, like double-digit percents. A lot of them are just an hour.
Micah, correct me if I'm wrong, but I think it's on the order of probably 30 to 40% of our millions of leases.
Okay.
Yeah, something like that.
And then for the compaction, have you guys tried defragment after doing compaction? there's a like comment called like defragment.
Oh yeah, that has to be done offline though, right? Is that?
Yeah.
Yeah, so we haven't tried that yet, because automatically cycling nodes in and out seemed a little bit risky, but certainly that's like a thing we could try. That might.
Yeah, because doing compaction is not gonna save the disk space. But like you guys running on like RAM disk, so it don't matter.
Yeah.
And then like apologize for the slow PR feedback on the.
Oh no, like we've been going back and forth a long time too. We appreciate it.
Yeah. We'll take a look. Yeah. Thank you.
And
We've had
we're
to do
busy.
a lot
We're
of
busy
data
with
gathering.
we're busy with a lot of other stuff too. So
Do you guys have any big upcoming things that you think you're going to need or scale dimensions you expect to see grow?
I mean, we hope to see all of this traffic increase. It means that we're doing well.
So kind of pretty stable.
I think we're kind of expecting that we might have to shard our current clusters, but
Okay.
not like imminently by any means.
Yeah, I would just kind of echo that. We've noticed that at least some of the times where we've broken our cluster just from traffic, that scaling back the amount of traffic by, even 20-25% can have a pretty significant improvement in terms of just like one of the things that really is important to us is the outlier request times. So, the 99th percentile and 99.9 percentile response times, we want to make sure that those are under a certain threshold. And so sharding is a strategy that we're investigating to make sure that we can keep those values low.
Gotcha.
Then, like, can you guys also open an issue with the node like rejoining issue that you guys mentioned?
Yeah, once we're able to reproduce it, it's like pretty tricky. Excuse me. We've been having trouble reproducing it, and it might be fixed by some of the other patches. I think the certainly like the least heap or the least rewriting one helps a lot, and I think like some of the other locking ones might have fixed it. But if we find it happening again, we'll certainly like try to open an issue.
Yeah, and I think we've only really seen this at a pretty considerable scale. And the reason that we don't know for certain whether or not the patches will solve it is because for our first use case that we talked about for the short-lived leases, at least, we're running in production on 3.3 vanilla. We're certainly not running our crazy patches yet until they're released. So.
Also, yeah, I thought you guys running master branch with the heap.
We were so kind of so we
pirate build.
So we've been calling it internally. We do sometimes feature switch our second use case on against a cluster running master branch actually 3.3 plus our patches, but we're not running it all the time. Mainly just to gather data.
Yeah, one of the things we were wondering is if you'd be interested in making a like point release of 3.3 for some like of the performance improvements which don't change any feature stuff. Is there like any thoughts about that? I know 3.4 is coming out in August now, I think, but we were thinking about maybe trying to get a stable build with some performance issues fixed.
Well, I don't think we're gonna do it, but we can help you test it. Like if you have a like Git commit or branch, we can help you test.
That'd be awesome.
Yeah.
That would be fantastic. That's really all we need.
Okay. Yeah. Just ping me. Any other questions? Okay, I think that's all we have today. Like, yeah, thanks everybody, and then thanks for the presentation. Thank you.
Thanks.
Thank you.
Thank you.